Hey YouTube, in this video we're going to cover GCSE ARCS sectors and segments. If you want my free study notes on the topic, then click the link down below, and please hit the subscribe button if you want future updates, and press the like button too. I hope you enjoy the video. So, what are ARCS sectors and segments? Well, if you look to this image on the left here, you can see that when finding the area of this sector over here, we divide a full circle by 4. Now, this is something that is by instinct, you guys would say that. If you saw this image, you would say, look, that's a quarter of a circle. Now, the question is, why is it that we immediately say that this is a quarter of a circle? Well, it's to do with the angle, right? We all know that this is 90 degrees, and 90 degrees is a quarter of a full circle, which is 360 degrees. So we know it's a quarter because we are doing 90 degrees, which is that sector, divided by 360. Then we can cancel the zeros. Then we can say 9 over 36 simplifies to 1/4. And that's, in very simple terms, the reason why we say that this sector is a quarter of a circle. So what we would do is we would do pi r squared for the full circle, and then we'll just divide it by 4, or do a quarter of the full circle. So the main skill for all of this, and then we're going to do the general formula and then apply it to some slightly trickier exam questions, is we need to make sure we know what fraction each sector is of the full circle that we're talking about. So if you look below, I have a sector here that has an angle of 300 degrees. Now, 300 degrees, if I wanted to work out the area of this sector, I first would have to work out what fraction 300 degrees is of the full circle. So we'll do 300 divided by 360, and then you would simplify. Any newcomers, I want to show you this. I'm going to do this with the calculator, even though you lot should know how to simplify fractions by now, right? All right, look at this. So fraction 300 over 360, which is cool, right? And then it does everything the same. So if you have your calculators, you can do this with me. So 5, 6. So, oh, let me get the thing back on. Next one, we got 50 over 50 over 360. This one's nice and easy to simplify because you can only cancel the zeros, right? So it's 5 over 36 of a full circle. And then the final sector, we're doing 250 divided by 360. And then again, nothing else really cancels there. You have 25 over 36. Now, using that skill, this is the main bit. This is what we want to know. We want to know, how do we do this generally? Because for the proper GCSE questions, we want to write down things generally and then apply it to exam questions. So can you therefore find a generic formula for the area of a sector and arc length? Now, what we mean by arc length is this length here. So that's to do with the circumference, right? So the arc length is part of a full circle's circumference. Now, if we were to look at the area, all I've done, when we say general, we don't give specific numbers. So here I'm using theta to be the angle at the center. So theta, you lot will have seen this hopefully in school. Yeah, the angles we like to use for, GCSE, well, in general, when we talk about angles, we like to use theta, alpha, etc. So you will have seen them before. So what we need to do is we need to work out what fraction is theta out of 360, yeah, like we did before. And then we multiply that by the full area of the circle. So theta over 360 just tells you what fraction that sector is out of the whole circle, and then we just need to multiply that by pi r squared. And that's it. That is the general formula for the area of a sector. All right, next thing is the arc length. The arc length. Now, the same thing applies when it comes to the arc length. All we're talking about now is the circumference of the circle. So all we're doing is we're saying what fraction is the sector of the whole circle, and then we apply that to the circumference. So if I was to draw a picture of the circle, oh, that circle is going so well. So you have the full circumference, the arc length is only like a portion of that full circle. Yeah, so again, we're just working out what fraction is theta over 360, but we just apply it to the full circumference. Now you can write the circumference in different ways. A lot of you might write pi d, but I want you guys to write it in terms of r. Yeah, so 2 pi r, 2 pi r. Yeah, we know 2 pi r is the circumference of a circle. All right, next thing. Let's apply this to some exam questions. So the diagram shows a sector of a circle. The radius is 8. Work out the perimeter of the shape. Now be careful, they're saying what's the perimeter of the shape? The perimeter is made up of 3 different things. There's the 2 radii, so the plural for radius is radii. Some people say radii, but I say radii. So it's 8 plus 8, but then also you have the full arc length. So we need to work out what that arc length is. Now the angle at the center here, we should know that if this side here is 90 degrees and the full way is 360 degrees, this should be 270 degrees. So the green, if I just write the green, you would do 270 divided by 360 times the full circumference of a circle, which is 2 times pi times the radius, which is 8. Now, when you lot get to A level, I hope everyone here is going to do A levels. 270 divided by 360, well, really, you should, if 90 degrees is a quarter, then 270 over 360 will be 3/4, right? But a lot of you would probably just type all this in the calculator, and I've got it here, so might as well use it, right? So if we were in the exam, this is what we would type. We'd do 270 over 360, then you would say times 2, and then you could say times. You don't really have to write the times here. Times 8, and you just write that down. So 12 pi. So the answer to that is 12 pi. It's also good for you lot to see how I type things in the calculator, because, you know, a very common thing when I'm teaching students GCSE is they don't yet know properly how to type things in the calculator. So when to use brackets, when not to use brackets. So this is super important. Then we got the yellow bits. The yellow, well, that's just the 2 radii, right? So it's 8 plus 8, which is 16. So the total perimeter is just 12 pi plus 16. Now you could type that in the calculator. The calculator would decimalize it, but I always say if the question does not ask you to decimalize, just write the full answer. Yeah, so if they do not ask you to decimalize, just write the full answer. All right, next one. This shape is made from 2 identical sectors. Work out the perimeter of the shape. Give your answer in terms of pi. Now this is an interesting one because you can see there 2 sectors like sliding on top of each other, right? So we have to be really careful about what we're adding together. There are some things that are quite clear in terms of numbers without having to work anything out. We have the 7 here, and you can see the equivalent 7 over here. Then on the other side, you can see this is 2, and this is also 2. So these we can work out really easily. The only thing that we need to calculate is these arc lengths. These arc lengths here in blue, yeah? So if we do it separately, we can say the green. The greens are easy, it's just 7 plus 7, 14 centimeters. Then the yellow, these are nice and easy, 4 centimeters. Then the next one is the blues. Yeah, so now the blue, we need to calculate the arc length. Now the angle at the center is 120. So it's 120 divided by 360 multiplied by 2 times pi times the radius. Now be careful, the radius here is 7, it's not 2, it's the greens. Yeah, the greens are the radius. And that's it, we type that in. Now another thing actually is, what do I need to do to that blue section? So I've done 120 over 360 times 2 pi r. What else am I going to have to do eventually to then get my final answer with that line? What else am I going to have to do with it whilst I'm typing it in? So we're doing 120 over 360 times 2 times pi times 7. 14 over 3 pi, yeah? Now this is where a lot of students go wrong, because what they're going to do is they're now going to add all these numbers up. Why is 14 over 3 pi plus the 14 plus the 4 going to be incorrect? There's one thing that I haven't done yet that's really important. We worked out that this is 14 over 3 pi. We need to double it because we got the other blue. So this is a very common mistake. Yeah, that happens. You'd lose a mark for this, but we need to be conscious about adding twice. Yeah, plus the 4 plus the 14. Then when you add this up, you'd get 14 over 3 plus 14 over 3 is 28 over 3. 28 over 3 pi plus 18. And that'll be in centimeters. That's it. Okay, here's a really cool question. It says, oh, gone too far. It says the area of this sector is 8 pi. Determine its radius. The area of this sector is 8. Now this is where we are working backwards kind of. So the angle at the center is 80. The angle at the center is 80. We divide by 360. Now the only thing we don't know is the radius, right? So we can't write pi, well, we can't say what the radius is. So it'll be pi times the radius squared. So this is the only thing that we don't know here. We're talking about the area now, yeah, rather than 2 pi r. Now they're saying that equals 8 pi. Now you want to make your life as easy as possible here. The first thing I would suggest you do is to simplify 80 over 360. You know, as a fraction, I think that would make life a lot easier. You know, in the exam, I would just recommend you put in there. So 2/9. What can we do to both sides? What can we do to both sides to simplify? Do you not notice anything on both sides that you could do here? By dividing by pi on both sides, we cancel it. And we can go from there. What's the next thing we can do to solve? You see it says multiply. So what we're going to do is we're going to divide by 2/9 on both sides. Yeah, so we're going to divide by 2/9 on both sides to get rid of this. We all know that the opposite of multiplying is by dividing. So we're doing 8 divided by 2/9. So you lot see my calculator? All I'm going to do is I'm going to do 8 divided by 2/9. 36. So we get r squared is 36. Next one. The last question I wanted to go through with you lot is finding the areas of segments. So OAB is a sector of a circle centered at O. Determine the area of the shaded segment. I like this because now we can use the calculator using sine and cosine and stuff like that. So what is a segment? A segment is this area here. We call that a segment. A segment is basically, if you take a circle, I don't want to do it where the calculator is, so down here. If you take a circle, imagine someone was cutting a cake really badly. Usually we cut the cake from the center, right? Imagine some lunatic just comes and cuts the cake like this. And then they take this piece off. That is what we call a segment, yeah? So we want to work out the area of the segment. Now the way we do that is we do the full sector. We do the full sector, which we've been doing this whole time. We do the full sector. And then we subtract the triangle. We subtract the triangle. So we're going to be using two formulas here. We're going to be using the sector formula. Now remember, the sector formula is theta over 360 times pi r squared. And then we have the area of a triangle, which Nadia has just told us is a half. AB sine C. Now, if you've not seen this formula before, it's really easy to apply. If you have a triangle and you have two lengths, A and B, and the angle C, all you do is do a half AB sine C, and then you work out the area of that triangle. So as you know, not all triangles are going to be right angles, right? So if we ever have a triangle that's non-right angle, we need one angle and we need the side lengths that wedge that angle to place, and then we can just sub it into the formula. So in our case, the sector, we've practiced this well now, is going to be 70 over 360 times pi times the radius, which is 10 squared. Now, let's put that in the calculator, still on screen. So we got 70 over 360 times pi times, I'm just going to say 100. 175 over 9 pi. 175 over 9 pi. 175 over 9 pi. Now, triangle. I'm going to show you lot something super cool here. So we have, where's my thing gone? There it is. Half. Now your A and B are the lengths on either side of the 70. Now I've only written the 10 centimeters, but the other side is also 10 centimeters. So it's a half A, B sine of the angle 70. Now look at this. I'm going to show you lot something super cool. So I'm going to type this in, half AB sine C. So half, bracket 10 sine 70. Okay, so you got 46.9846, etc. Now, how many times have you lot been doing a question where you've forgotten or you've not written the full decimal down, and then you've had to retype it in the calculator because you didn't write down all the digits? In these calculators, even in the old calculators, you can do this. You can store these numbers as letters, and then you can revisit them whenever you want. In these calculators, which I'm going to tell you lot to buy, can you see it says STO here? STO means store. So I'm going to press STO, and then on the top here, can you see it says A, B, C, D, E, F? I can store this number as a letter. I'm going to click this button because it says A. Can you see now it says answer has been attached to the letter A. So look, if I clear this, even if I turn the calculator on, can you see the screen's gone blank? If I do alpha A, it has always stored my answer as this number, meaning I can come back to it whenever I want. So all I need to do is I just need to write down a few digits here. So what is it? It's 46.984 dot dot dot. But remember what we're doing. Yeah, we're doing the full sector area, which was 175 over 9 pi. And then we are subtracting that 46.984 dot dot dot. But again, we don't really want to type, we don't really want to write all of that down, and we don't want to type all of that down either. So what we're going to do is we're going to use the A button to do that for us. We're typing this all in. So we're doing 175 over 9 pi. Now, instead of writing that whole long decimal, that 46.98, that's long, right? All I'm going to do, alpha A, and there you go. There's my answer. How quick was that? So that's a super cool thing that, again, you've learned today. Hopefully you will use this with your calculators. So let's write that down. I'm going to say 14.1 rounded, yeah, centimeters squared. If in the exam they don't tell you what to round it to, please do 3 significant figures. If you read the front of the exam paper, it always says, if we don't tell you, then round it to 3 significant figures. One more question to do. So the diagram shows a circle, center O. A and B are points in the circle. The radius is 6. The value of sine of 30 is a half. Work out the area of the shaded segment. Leave your answer in terms of pi. Now, same thing. We're going to do the area of the sector. Sector area is 30 divided by 360 times pi times the radius squared. Now, we can actually simplify this without the calculator. The zeros cancel. 3 goes into 36 12 times. So it becomes 1 over 12. I think we are all happy with simplifying fractions, yeah, hopefully. 6 squared is 36. Now remember, over 12 means divide by 12. So we're doing 36 divided by 12, which is 3. Then we have pi. So the area of the sector is 3 pi. The next thing we have to do is the area of the triangle. Now remember, the area of a triangle is a half AB sine C, a half. AB, the A's and the B's are the 6's. So a half 6 times 6. Sine of the angle, sine 30. Now in the exam, you may have a you may have a non-calculator paper where you need to know the values of sine 30, tan 30, cos 30, which we will address another time, but you do need to remember them. This is a non-calculator paper. So I have been generous and told you lot that sine 30 is a half, and you can verify that in your calculator. So we need to work out what a half times 6 times 6 times a half is. Well, that's easy. A half of 6 is 3. 3 times 6 is 18. A half of 18 is 9. Yeah? So the answer to that is 9. Then finally, the segment area, like before, is we take the sector area, which is 3 pi, and then we subtract the triangle area, which is 9. And that's your answer. We could say centimeters squared. Right guys, I hope you learned something new today and you enjoyed the video. If you did, feel free again to subscribe and like the video. Share it with your friends if you feel like it will benefit them as well. And as I said, if you do want a free cheat sheet to this topic, then make sure you ping me on WhatsApp and feel free to follow me on Instagram as well. All the details are in the description below, and I look forward to seeing you in my next video. Peace.